Hi everyone. So today we'll be presenting about text summarization with large language models. And in this project, we have used the BART model. We are group 141. So let's go ahead. Motivation and the problem statement. So motivation around our problem was the LLMs like ChatGPT have transformed how we process and understand language, especially in real-time conversation. So we want to have a tool that manually summarizes the dialogues, and currently that is very slow and inconsistent. So our goal was to fine-tune a pre-trained BART model on the Samsung dataset to generate accurate and concise chat summaries. This is the dataset overview. As you can see, we have the dialogues where conversation happens and we provide them with the summary. So this is a Samsung dialogue dataset from Kaggle, and it uses 16,000 chat dialogues with human written summaries. And we have split that into training, validation, and test examples. And it is ideal for training and evaluating dialogue summarization models. This is an example again for the input and output description. So the input is, let's say we have a news article, and the output is a summary of the news, which provides a short, coherent summary that captures the main points, actions, or decisions made in the conversation. Let's go ahead for the baseline model BART. So BART is a bidirectional and autoregressive transformers, which is a sequence-to-sequence model, which combines the benefits of both BERT and a GPT model. The architecture includes the encoder and decoder structures, whereas BERT is purely encoder and GPT is purely decoder. And we have used both of them and combined that with the GELU activations, which are much smoother and often more effective than ReLU. The model uses a shared embedding layer, which follows an encoder-decoder structure with 12 layers each for encoding and decoding. And each layer has its own multi-head attention, GALU activations, and the layers are fully connected. We have also used layer normalization for stability. The decoder features both self-attention and the encoder-decoder attention, and the final output is generated through this linear layer, mapping to the full vocabulary. Here's a screenshot of the architecture of our model. As we can see, the encoder layer has 12 layers, and along with that, we have GALU activations and layer normalization at the end of it. And similar architecture is seen in the decoder layers as well. So we have 12 decoder layers with GALU activations, and the token number of tokens that we have produced is 1024. So next step is fine-tuning the BART model. Why was it needed? The BART model is pre-trained on a large text corpus, but not specialization for summarizing the dialogues. And the Samsung dataset contains informal chat-like data dialogues requiring the customized summarization behavior. So we have used this dataset to fine-tune our model to make it more acceptable to the dialogues, and it provides summary of the conversations. So fine-tuning allows it to learn the style, the structure of the human written summaries, and improve the relevance and informativeness of the outputs. We have used sequence-to-sequence trainer pipeline, which combines the BART model, the dataset, the tokenization, and the evaluation metric that we'll talk about. So this is a screenshot of how we have used the sequence-to-sequence training arguments. So the fine-tuning setup was used to define all the arguments. As we see, we have the learning rate as 2 into 10 raised to the power minus 5, and the batch size was 4. And we trained this only on 4 epochs because of the computation expenses. And evaluation strategy was that at the end of each epoch, we load the best model at the end, and it saves on the validation loss. So this is again, we use the sec2seq trainer, and it is performed, which integrates the BART model and evaluation metrics. As you can see, we received the lowest validation score of 1.44 in the epoch 2. And in the epoch 2 only, we see all the metrics like Rouge 1, Rouge 2, every metrics has the highest value. So the evaluation metric that we are talking about, Rouge, is a score for summarization. It measures the similarity between machine-generated and human-written summaries over using the overlapping words. So Rouge 1 means only one word would be taken and would see if it is overlapping in the summary, or Rouge 2, Rouge 3, based on the number of n, we evaluate the performance on unigram, bigram, or diagram. Rouge L is the longest common subsequence, which identifies the shared sequence in summaries and ensuring the content coverage and structural alignment. Root scores for our supervised fine-tune model was around 153 for Roach 1 and 29 for Roach 2, which is a decent jump from the baseline model. Future scope, we can explore our larger models. We can fine-tune larger models like BART large, that is more in parameters to capture more nuanced dialogue context. We can experiment it with other data sets as well and incorporate reinforcement learning that uses a reward-based fine-tuning model to better align the summaries with human expectations, and some multilingual or cross-lingual summarization. prior work, we have one of our team member working on sentiment analysis program, which is kind of similar, and another team member has experience with building a chatbot. So all in all, we applied all this previous knowledge to focus on fine tuning the BART and use that in text summarization. These are some of the references. Thank you so much.